Okay, so on this, if we look at these two triangles, in this triangle, AB is 3. The angle is 123. How long is AC? 3. Because every radius of a circle is congruent to itself. So in this circle, ED is 3. DF is 3. And that angle in between is 123. So what can I say about the length of EF? It must be 5.27 because, here, just a second. I got to go like this. Boom. Now I got numbers. This has to be 5.27 because if this is 3 and this is 3 and this is 123 and this is 3 and this is 3 and this is 123, by SAS, these two triangles are congruent. So if these two triangles are congruent, then all the sides have to be congruent. All right, vocab sheet. There we go. A chord is a segment whose endpoints are on the circle. We're going to talk about chords today. It's an easy concept today. Chords. A segment whose endpoints are on the circle. A chord is a segment whose endpoints are on the circle. All right. So in that circle right there, why is RS, this one, congruent to TU, this one? Well, what can I say about QS and QR? They're both radiuses of the circle, so they're congruent to each other. What about QT? That's also a radius, so that's congruent. What about QU? That's a radius, so that's congruent. So all the radiuses are congruent. We don't know yet whether SR is congruent to TU, but there's an angle that we know. Angle RQS, this angle, is congruent to what angle? TQU. Why are they equal? Because they're vertical angles. And so then by side angle side, these two triangles are congruent, which makes SR congruent to TU. Okay? So it brings us to this. If this chord is congruent to this chord, then this angle is congruent to this angle. Okay? Or if we start out with this angle congruent to this angle, then this chord is congruent to this chord. Okay? Converses of each other. And if this chord is congruent to this chord, if they're the same length, then the arc that they intercept is congruent to the arc that they intercept. Or if this arc is congruent to this arc, then this chord has to be congruent to this chord. And you ask why? Well, if we just draw the lines, this is congruent to this is congruent to this, and this is congruent to this, so it makes those equal. Okay? All right. Now, if two chords are equal in length, they're the same distance away from the center of the circle. Always, always, always. If two chords are the same distance away from the center of the circle, then the chords are equal length. Always, always, always. So I'm saying the converse of everything that we've taught so far. Okay? If this is congruent to this, then this is congruent to this. Or if we start out with this is congruent to this, then this is congruent to this. So, looking at this, let's say AB is 6 long. Okay? If AB is 6 long, then how long is DC? 6 long. What do we, if FS is 4 long, then how long's ES? 4. Okay? Easy peasy lemon squeezy. If EF is congruent to EG and CD is 40, how long is AB? How long do you think AF would be? How long do you think AF is? 20. Okay? Because what happens is when a chord hits a radius perpendicularly, it splits it into 2 equal parts. So those are equal, which says right here. If a radius is perpendicular to a chord, it splits it into 2 equal parts. And if a chord is split into 2 equal parts, it must be perpendicular to the radius. Okay, so that's all the easy stuff. Now for what we have to think a little bit more, okay? We have a spherical vase here, and they put flowers in it. The flowers need to be in at least 4 inches of water. Are they in 4 inches of water at this point? Well, let's see. If the diameter of the sphere is 6, what's its radius? 3. Its radius here is 3, which means if you go from here to here, it's also 3. So we need to know the distance from here up to the water, right? Just to make sure that that's 4. Well, how do we figure that out? Well, I know the distance across this is 5, right? So this is a right angle, so this is 2.5. If I only knew this distance right here, then I'd have a triangle. Do I know this distance right here? Yeah, it is 3. If this radius is 3, then this radius is 3 because this radius is 3. Every radius is 3. Okay? So now we have a right triangle, so we can use the Pythagorean Theorem. 3 squared equals 2.5 squared plus x squared. That's what problem number 1 was about on your quiz. The Pythagorean Theorem. So 9 equals 6.25 plus x squared. If we subtract 6.25, we get 2.75 equals x squared. If we take the square root of 2.75, we get 1 point. About 1.7. So 3 plus 1.7 is 4.7. Are the flowers in enough water? Yes, they are. All right. Enough with logic. Yeah, we have math. Why use logic? All right. All right. Imagine that if we look from kind of at an angle, there's a circle formed by this water, right? And if a goldfish requires 50 square inches of water surface, that's a circle at the top to be healthy. How many fish can live there? Well, to figure this out, we need to know the what of this circle? The radius. And we'll get to the area, but we got to start with finding the radius. We got to find the radius of that. Now, if the sphere has a diameter of 12, then the radius of the bowl is 6. But is this radius up here 6? No, it's a little bit shorter. But I know if this is 6 here and this is 6 down here, what's this right here? How can I figure that out? This is 2. If I use this, which is 6, then how long is this radius? I can figure that out by using the Pythagorean Theorem. So 6 squared equals 2 squared plus r squared. So 36 equals 4 plus r squared. Subtract 4. 32 equals r squared. Take the square root of 32. 5.7. So we need to find the area of the circle, which is pi r squared. Well, If you take the square root of 32 and square it, it's 32. So basically we're taking 32 times pi. What's 32 times pi?
100.5.
Now, if a goldfish needs 50 square inches of water, how many goldfish can I put in this goldfish bowl? 2. So they can be happy goldfish. They can be swimming around with each other.
What is that? No. It looks like a face. Like it's terrifying.
All right, so there's our extra goldfish that can join its buddy in the bowl. Its buddy does want some company, so there's the extra goldfish. All right, so if this is congruent to this, then that makes this congruent to this. If this is congruent to this, that makes this congruent to this. Okay? Chords and arcs. Fairly simple concept today. Let's get going with this.